Okay. Now, whenever we are talking about color, right, white light, we all understand that white light is comprised of multiple colors. Do we agree? Have we all seen a rainbow before? We've all seen a rainbow, right? So if we look at what I have currently here on the screen, I have three colors: red, green, and blue. All right, what do we know that color mode as? RGB, okay? In the center, where red, green, and blue are combined, what color do we get? White. Okay, so the visible spectrum, has anybody played around with prisms before? Okay, the visible spectrum of white light is comprised basically of these three primary colors: okay, red, green, and blue. This is called an additive model. When you take all three of these wavelengths together, and light is a wavelength, when you take these three wavelengths together and you combine them, you get white light. Which means if we take white light and we break it apart, that's exactly what you're seeing in a rainbow, right? You're seeing that refraction of all the different wavelengths that are actually hitting all at once. You're seeing the separations of the individual colors. Are we okay with that definition? And now there's more to it. I'm not going to get into the scientific deep end of the, color theory, but we understand that white light is comprised of these three primary colors. Now, if you'll see where the colors interact, this is kind of like a very colorful Venn diagram. If you take a look at where red and green intersect, what color is there? What is it? Yellow, right? We get a yellow where red and green intersect, which means when you combine a red and a green light wave and it hits basically the rods and cones in our eye, our brain interprets that as yellow. Does that make sense? Now look at blue and red. When they intersect, what color does that make? Magenta. Okay, suddenly does some of this starting to make sense. When red and blue wavelengths are combined and hit our eye, we end up with magenta. And then therefore, blue and green create what color? Cyan. Okay? So we have three colors, red, green, and blue, within the visible spectrum, and when you add them together, it's called an additive model, you're able to create colors. All three of these colors together create white light. Okay? However, the secondary colors from the additive model happens to be cyan, magenta, and yellow. And you can see that here in this diagram, right? We have cyan, magenta, and yellow. So, I'm going to move over here and let me put these three colors together. Cyan, magenta, and yellow is part of what we would call a subtractive color mode. These are the primary colors in a subtractive color mode. And I'll explain what the word subtractive means in just a minute. But here's what we need to understand. These two color modes are used in two different situations. The red, green, and blue are the additive color mode, where we add color light together to project secondary and sometimes tertiary colors, is used when you are displaying something with light. For instance, the screens all around you, the monitors, your phone, these TV screens up here, this projector, they're all projecting light. Do we agree? All of those devices use this RGB color mode because they're built with little itty bitty pixels of red, green, and blue dots. And those red, green, and blue dots turn on and off at certain percentages to mix together light waves that our eyes interpret as color. That's an additive mode. It's used when you are creating images using projected light. TVs, projectors, monitors, all of that uses projected light. However, when we are talking about printed items, like this canister that I showed you from Starbucks. This has color on it, can we agree? Is this emitting light? Is this creating its own light? No, it's a piece of cardboard, right? I mean, that would be kind of neat, but it's not the case, right? This doesn't have a light bulb in it. This doesn't have LEDs. Does everyone understand what I mean by emitting light? So then how in the world are we seeing color if we can't emit light? Well, light is reflecting off of this surface. Do you agree? When the light is reflected off of this surface, certain colors absorb certain wavelengths of light. When you absorb a color, you are subtracting it. Does everyone understand that definition? So, if we take a look at these three colors over here, remember, this is a mix. Let me kind of move this down a little bit. This is a mix of red, green, and blue, right? So take a look at the cyan. Cyan is when you mix green and blue together. Everyone agree with that? Yellow is when you mix red and green together. In other words, yellow is the absence of what color? You don't have blue in yellow, correct? All right. Cyan is the absence of what color? Red. Magenta is a mix of red and blue, but it's an absence of green. Right? So we can say these things are true. Cyan absorbs the red color. In other words, it doesn't reflect it back to your eye, right? It sucks it in like a black hole. It subtracts it from the visible spectrum. Do you hear the words I'm using here? It removes it, it absorbs it, it subtracts it from the visible spectrum. So when you are seeing the color cyan, here's what's happening. White light is hitting, like let's take a look at this tin. We can agree there's some cyan in here, right? Here's a good example of cyan mixed with what looks almost like magenta up here at the top, right? The areas of cyan that you see in this tin, what's happening is that the white light around us is coming and hitting the ink that's on this paper, but the ink is mixed in such a way that it absorbs the red light waves, right? So what happens is what is reflecting back? Well, what's reflecting back is what's left over. Well, out of red, green, and blue, if red gets sucked up or subtracted, what's left? Green and blue. And when that green and blue light reflects off of that little part of the paper and hits my eye, what does my eye interpret it as? Cyan. Do you see how that works? The subtractive color mode is what we use in print. Everything that we print, including your t-shirt, right? It's a great t-shirt, love Batman. It's a green shirt, right? Okay? Well, take a look at this. How do we get a green dye for a shirt? What two colors here, if we mix them together, create green in the CMYK? Cyan and yellow. Does everybody see? If I put cyan and yellow together, what is reflected back to me is green. Well, why? Well, cyan subtracts or sucks in the red, right? Yellow subtracts or sucks in the blue. If I remove red and I remove blue, what am I left with? Green. So, because I am subtracting red and I'm subtracting blue, the only visible light that I can see is green. Does everybody see how this works? Okay? This is how printing operates. And the reason why we use CMY as the primary colors and subtractive modes. Anytime you are going to reproduce something that is using reflective light, it's not producing its own light like a monitor, that would be RGB, but it is reflecting light. What we have to do is we have to think about, okay, in order to create a color, we basically have to suck away everything else, right? So whatever's left is a mixture of the colors that we want to create that visible light. So it takes a little bit of time to kind of get your head wrapped around this, and today's assignment is going to be to help you out with this. So here's what I want to do, just so that we can kind of play around with this. Let's go ahead and let's create, I'm going to create a new artboard here, just like you guys have. Let's go ahead and in your artboard, I want you to grab maybe it could be the ellipse tool, it could be a square, I don't care what shape it is, doesn't really matter. And I want you to first draw a shape on your artboard. But here's what I want you to do. First off, remove the stroke. We only are going to work with fills today. Okay? So let's remove the stroke. So I'm going to come up here and I'm going to remove this stroke. There we go. All right. Next. Now I've got this shape. It's just white. That's not helping me. The next thing that I want to do is I'm going to change the fill. So let's bring up the color palette. So where can we go to find the color palette? Anybody remember? Where was it? You could do it here, right? The swatch, but there's an actual color palette itself. Yes. Window. Yes. So if you go under window, right? You can come down here to color. And you have the color panel. Now, if your color panel currently does not say CMYK, if it says RGB, make sure you didn't set yours up as CMYK. That's fine. Click on this little hamburger icon in the top right hand corner and make sure yours says CMYK. Okay, now here's what I want to do. I'm going to fill the shape with one of the three primary colors, either cyan, magenta, or yellow. I'm not going to mix things together, just one color. So pick a color. I don't care which one it is. Cyan, magenta, or yellow. Not black, just cyan, magenta, and yellow. I'm going to choose magenta. Okay? Everyone with me? Good. Now, let's do the same thing. Create another shape. Doesn't matter what the shape is. Remove the stroke. Give it a fill. But change the color. So I used magenta this time. Maybe I'll change the next one to cyan. Okay. Now you can do that a couple different ways. You can grab the shape tool again. You can draw another shape. I can copy and paste this shape. Copy, paste, whatever you want to do. If you want to, you can also hold down the Option key with the Select tool, and that will create a duplicate as you drag. So either way, create a shape and fill it with a different color. Now notice, when you overlap these shapes, we're not mixing colors all of a sudden. Do you see that? It's not doing like what I had up here at the top. So up here, everything is kind of like mixing together. How in the world is that happening? Well, we have to do one other thing in order to see these colors the way that our eye would normally see them and be reflective. We have to change what's called the blending mode. Now, has anybody here played around with blending modes before? A couple people have, okay? So the blending mode that we are going to use, we want to basically combine these two colors together, right? We want to basically multiply them together to create whatever color that we should see. So to do this, here's what I want everybody to do. First off, from the window menu, open up the transparency palette. Bless you. Go to window, come down here, and find transparency, please. Does everybody have that? Now, in the transparency, we're going to ignore the opacity, because here's what the opacity does. You go, oh, look at this. I can change the opacity, and I can kind of see through it. Leave it at 100%. Don't want to do that. That's not what we're doing. What we want to do is we want to change how these things blend together. So, select both of our shapes. So you can just drag a selection around them, or just click on one, hold the Shift key down, click on the other. Doesn't matter. Select both shapes. From the transparency panel, does everybody see the drop down that currently says normal? These are our blending modes. Now, there are a lot of blending modes, and we're going to go over what a lot of these are. But for right now, The only one that I want you to focus on, the only one that exists to you today, is the one that says multiply. So click on multiply, and you will suddenly see, if you overlap these shapes, you will suddenly begin to see those colors begin to mix. Now what's happening here, in the case of my two colors, I have magenta and I have cyan, right? Now remember, one of these colors, when you overlap the two, I get blue. Does everybody see that? Which means that when I overlap cyan and magenta, what is being subtracted from the visible light is red and green. And I'm only left with blue. Does that make sense? Okay. Now, multiply as a blending mode allows us to do this. We're able to actually put two colored shapes or multiple color shapes. I can add more if I want, as long as all the shapes are set to multiply. I can overlay these and I can create colors. So for instance, let's change this up a bit. Instead of my cyan, I'm going to come over here and I'm going to make this yellow. So now I have a yellow and now I have a magenta. What color do I have in the middle? Red. Right? Does everybody see that? But what if I take the magenta, and you see that right now I currently have the magenta set to 100% magenta, right? What if I lower the percentage of the magenta to say something like 50%? What color do I have now? Orange. Does everybody see that? Okay, now we're starting to see how things work and why, when we talk about printing, we really only talk about three colors, for if you add black. Just like the RGB color mode can add any combination of red, green, and blue and reproduce any colors with visible light, the CMYK color mode can mix cyan, magenta, and yellow to absorb or subtract certain wavelengths in order to reflect back a mixture of wavelengths that reproduces any color in the spectrum. Does everybody kind of see how this works? So, before we move on, just out of curiosity, I think I mentioned it before, but maybe not. Who discovered, not invented, who discovered this concept of visible light? Does anybody remember? I'll give you a hint. He also was the one who discovered the concept of gravity. Isaac Newton, right? Sir Isaac Newton. Let's give him credit. Dude was a sir. Sir Isaac Newton, right? The guy, the apocryphal story of an apple falling on his head. Does everybody remember that from school? Okay. Same guy played around with glass prisms and discovered the concept of visible light. That white light broken out into its composite wavelengths basically kind of creates this primary color of red, green, and blue. Then, as we start to look at how reflective light produces color by subtracting wavelengths, now we start to understand the concept here of how CMYK is used in printing. How are we feeling so far? Okay. Now, to this end, let me show you something here. Okay. This printout right here, and I'm sorry, I'm doing a screencast, so I apologize if anybody is watching the screencast later on. You're not going to see this, but take a look at this poster. This looks like any other typical poster, right? I think this was an ad for Dillard's, I think at some point in time, right? You've seen things like this all the time, right? Well, how is this created? Well, this is created by printing cyan, magenta, yellow, and black as a key to create this. Now, black, or K, is used in printing not because we need it to actually create a color, because remember, if we come back up here, when you mix cyan, magenta, and yellow together, what color do you get? Look right here in the center. You get black, right? So then why then do we have a K in CMYK? Why do we have a black? The black itself is used to give additional contrast. Okay? It's what we call a key. And so we use CMYK to reproduce all sorts of things. Now, the interesting thing is that how this is printed on a press is that it's not printed just like this. Like your normal laser printer, you just hit a button and out pops a color page, right? How many people have like inkjet printers? Have you guys ever used inkjet printers? No? I know, this younger generation, most of you all have never owned a printer, which blows my mind. But anyway, point is that how this is actually printed is this is printed basically 4 times. The first time it's printed with one of the 4 colors, cyan. Then it's printed again with just the magenta colors. Then it's printed again with just the yellow colors, and then it's printed with the black. So every single time you see a print, what's actually happening is that the individual 4 colors are printed on top of each other to create this. Now, to show you what I mean by this, let me jump into Canvas. I've got these videos. I'm going to throw this up on Canvas later on, but let me show you this right here. Check this out. Now, this is screen printing using CMYK colors. Okay, what are they printing on? In this case, they happen to be printing on a t-shirt. But can we agree, a t-shirt does not emit light, right? It's not producing light. We don't have LEDs in our, most t-shirts don't have LEDs and stuff in them. Agreed? All right, so here's what you're going to see. You're going to see that there is a series of screens that they're going to place down. Now, how screen printing works is that there is a photo emulsion that's actually added to the screen, and you basically burn in the image that you want. And then you wash that image out after that screen hardens. Only the part that hasn't been exposed to light stays kind of malleable, and you can wash that out. Now, how this works is that as you are creating your design, they separate from all the colors that you're overlaying. They separate out just the cyan, just the magenta, just the yellows, and just the blacks. This is called 4-color separation. Okay? So then you have a screen that is only going to include the cyans that you need, and then the yellows that you need, and then the magentas that you need, and then the blacks that you need. And when you lay these screens on top of each other and you lay out the color, you will see this particular design come to life. Check this out. So that's the yellow. The screen looks blue. Just look at the ink. Everyone see how that's a yellow ink? All right, now notice the design is just in yellow, right? Okay, he's going to go to the next color. What color ink is that? Yeah, it's kind of like a magenta. So they're squeezing it just through the parts that need to be magenta. Now notice, cyan and magenta on top of each other, right? Or excuse me, that wasn't cyan and magenta. Yellow and magenta on top of each other. Notice now you have an orangish hue. But the whole thing isn't orange. Move on. Now what color are we doing? This is cyan. Okay, so now we are mixing 3 of the 4 colors together. Ah, does everybody see this now? So check this out. Look at the beak. The beak is still fairly orange. Does everybody see that? Now, what's happening here? The screen that has the cyan, remember, to get orange, you're mixing what two colors? Magenta and yellow. Remember that? Magenta and yellow will give you red, but depending on the percentage of magenta, you'll get an orange when you mix it with yellow. So how are they producing that orange beak? Well, the screens for this eagle, for the magenta and the yellow, are open so that the inks can actually flow in that area. So you're getting magenta and yellow in that spot of the shirt. Okay? When you bring the cyan in, the cyan screen itself doesn't have any space for the beak. So none of the ink goes in that area. Okay, so the only two colors you're mixing there to get that orange is that magenta and the yellow. However, look at the banner underneath. Does everybody see how the banner is kind of a darker gray-black area? Remember, what happens when you add magenta, yellow, and cyan together? All three of them together create what color? Black, right? And depending on the percentages that you do, you're going to get different gray tones. So that banner down at the bottom, on each of the three screens that you just saw, have different openings for magenta, cyan, and yellow. So all three of those colors are mixing there to reproduce basically or subtract light so that you kind of have this gray tone. And then finally, look what happens to the image when you add black. This will make it pop. This will add contrast. Watch this. Everybody see that? So that adds contrast and definition. Do you see how these four colors together can create this? So again, from this particular photograph, we actually have multiple separations. First off, the black, the key plate. Look at the yellow. Cyan. Look at the magenta. Do you notice here the text? See how much magenta, how dark the magenta is there? Right? That's 100% magenta. Notice how it's lighter here? It's probably closer to like 60% magenta. Look over here though in the cyan. Look at the text in the cyan. How much cyan is actually getting in that text? Just a small amount. And that, when those two come together, there's no yellow by the way or black. When this little bit of cyan and this ridiculously dark magenta come together, it's when you're getting this color together. Do you see how this works? So, in order to produce this, what we end up with is we end up having to take these four colors and reproduce this design with different percentages of magenta, cyan, yellow, and black in different areas of the design. And when all of these are printed in order, what comes out the other end is this. Does everyone see how this works? So these are our four color separations. If I were to take that finished design and tell it, I just want you, I want to get rid of all the cyan, yellow, and black, I would just end up with something that looks like this. Right? If I told it to get rid of all the magenta, yellow, and black, I would end up with just the cyan. Same for the yellow and the black. Does everybody see this? Okay. So, I'm going to leave these up here, and you can come up here and kind of investigate and kind of take a look at these. But the same thing happens in every print. Every single thing that's printed is a composite of magenta, cyan, yellow, and black. Okay? So what we're going to be doing today, just so we can start to kind of wrap our heads around these colors, like how in the world these colors are actually made, we're going to recreate, or we're going to create a new robot. Remember the robot from assignment 2? Okay. Except this time, our robot's going to be made up of color. However, we are not going to be making color by creating a shape. Let me show you this. This is what we're not going to do. We're not going to create a shape and then in our color panel mix all of our CMYK colors together like this. This is going to be invalid for today's assignment. So everybody see how this particular shape, let me make a kind of a purplish color. How about that? We'll do that. Something like that, okay? It's like, oh, I want to make this color. I could just go here in the color palette and just kind of mix these things together. Nope, you're not allowed to do that. If I want this color in my robot, right? That is a combination of cyan at 36%, magenta at 100%, yellow at 4%, and black at 37%. Does everybody see that? So here's how I need to reproduce that in my robot today. I need 4 shapes. So let me show you what I mean. So I'm going to create, whoop, no, that's not what I want. There we go. No. Go back over here. There we go. I'm going to create, so let's, let me write this down just to make sure I remember what it is. So what I need is I need a cyan at 36, right? A magenta at 100, a yellow at 4, and a black at 37. Does everybody see that?
So it's okay if we do it this way to get an exact color we want, or do you want us to
Yeah.
just mess with
No, if you want to like mix the color together to figure out what the percentages are and then reproduce it by overlaying the shapes, that's fine. Just make sure that if you actually have a shape made up of CMYK or more than one color, it's off into the pasteboard area. I don't want it to print. Okay? So if you want to just like have this, for instance, if I just want to have this shape just sitting over here in the pasteboard area and this is going to be my color mix swatch, my little palette that I'm going to play around with, that's fine. But over here, I'm going to take my rectangle tool or my shape tool, and I need, first off, I'm going to need a shape that is at 36% magenta, or excuse me, cyan. Does everybody see that? Now here's the thing. I need to make sure that the blending mode for all of the shapes that I'm overlaying are set to multiply. Okay, so I'm going to do that. I'm going to go ahead and I'm just going to drag this down here. So the next color that I need is I need magenta. I'm making this color here. I'm going to make this with 4 different shapes. I need a magenta set to 100%. Okay. All right. And I'll make another duplicate of that. All of these are set to multiply. Then the next shape I need is going to be yellow set to 4%. Okay. Doesn't look like it's done a lot, but it's there. And then I'm going to make another shape, and for that I need black set to 37. Now, does everybody see where these 4 shapes now interact is this same plum color? Okay? So I can now take these 4 shapes if I want. Maybe I want them to kind of like overlap a little bit. You know, just kind of like not quite kind of, you know, maybe that's going to be part of my robot design. That's fine. That's the color that I want. Maybe I like having these little overlaps. That's cool. You could certainly do that. Or if I want all these shapes to be aligned together, I can of course go over to properties, and remember we have these alignment. I can align these things together and I can create that color. Okay? So everybody see how that works? I was able to add them all together to kind of create the color that I want. Question?
Can we group the shapes together?
You can, yeah. If you want to group them together, that's fine. Because here's how we're going to actually turn this assignment in. The assignment is going to be turned in with 5 printouts. We're going to print, basically, it's going to be like this. Now, here's the problem, though. I wish all of you had access to the color printer. If you don't, that's fine. We're going to print them out on the black and white. But what's going to happen is, is imagine here for a moment that I'm printing. So I've got this color here. I'm just going to move this out of the way. We have these shapes here, right? And these shapes are made up of, wait, what did I do? I just deleted the black, sorry. These shapes are made up of CMYK, right? So I have 4 colors in this one shape. This is made up of magenta by itself. This one is made up of yellow. Does everybody see that? So let me add another one. I'm going to add one that's cyan here. Make sure it's set to multiply, and I'll give this one full cyan. Okay? So, does everybody see the shapes that I currently have here? All of these shapes are set to multiply. Okay? Now, if I go to print out my design, by default, Illustrator is going to print a composite. In other words, it's going to print all 4 colors all at once, going to come out of that printer. Okay? So, to give you an idea, let me see, let me do artboards. Artboard 3, there we go. So, here is the artboard. Okay? Now, if I print this out, this is going to print a composite. How do I know that? Here in Illustrator, if you go to the output, it'll ask you what mode you're in. And by default, it should say composite. Okay? I was playing with this earlier, so I had changed it. It should say composite. So when I go to print this, it's going to print this entire design. Now, the problem with that is, and I'll print it right now, when this prints, it's going to be printing on a black and white printer, right? It's going to be basically in grayscale. Agreed? I know I can print to the back printer, so I'm going to do that. Oh, that's a little bit 2. What's a little 4? There we go. Okay. So, here's what it looks like. That doesn't look so great, does it? Well, I've got a color print going on right now. However, you notice you see all the shapes, right? It's a composite of all 4 colors. If I were to print the exact same thing again, go to output. Oh, goodness gracious. Come here. Output. What in the world? Oh, right. Wrong one. There we go. If I go to output and I go to separations, here's what's going to happen. You'll notice down here, when I choose separations, it's going to say, okay, you're going to print 1 at cyan, 1 copy in magenta, 1 copy in yellow, and 1 copy in black. Does everybody see that? Okay. Now, usually you could print a resolution, but I don't think it's letting me do this because of the printer that I'm printing to. So I'm going to print this out. It's going to print over here on this black and white. I have no idea why that thing is not printing back there. It's printing more than 1 page. There's 1, there's 2, there's 3, there's 4. Here's the composite. First page. See that? Okay, actually it's upside down. Sorry. There we go. So, does everybody see what color printed? Cyan, right? So look how the bottom of my design, the circle is in cyan. So everybody see how the circle got printed here? Okay? Or how is it like this? Like that? Yeah. Okay? Why did the block print?
One of them has cyan.
Because one of the 4 colors that make up that plum is cyan. Does everybody see that? Which means every single one of these pages should have this square on it, right? Okay, so that one's cyan. Magenta. See that? Notice the circle's missing. Why? Because I told it to print magenta, and the circle is cyan. This one's yellow. You see the big giant square in the middle? Notice the magenta square is missing, as is the cyan. But again, because this little square up here in the corner is made up of all four colors. You see how it's printed? Okay. What color is that? Black. These three shapes are cyan, magenta, and yellow. They don't have black in it, right? But remember, this has 45% black. So the only thing that printed was black. Does everybody see that? Okay. So, in addition to that, do you see how this square, this being the yellow one, right? Do you see how this yellow printed very dark? This is a dark black color. And then this one's kind of a lighter gray. That's because the percentage of yellow that made up that particular rectangle was fairly low. So you're going to see the percentages of the colors are going to be represented in grayscale. Does that make sense? Okay. This way, I can actually see how you did your color separations, how you created those colors. I will be able to see the individual shapes. Additionally, I can actually separate all these out. So I will know whether or not one of your shapes is wrong because you ended up mixing a bunch of colors together for one shape instead of overlaying single colors together. Does that make sense? Now, in Canvas, I'm going to come back. I've got a couple other ones I'll show you here in a second. But in Canvas, let's go ahead and go to Lesson 5 module, and let's go to Assignment 7. And let's talk about this really quick. Here's what you're going to turn into me. You're going to print out a composite and a 4-color separation of your finished work. Okay? You're going to staple that together and you're going to turn that into me. In addition to that, your finished Illustrator file, I want you to upload to Canvas. Now, the setup of this file is going to be a little different. First off, make sure it is a letter-sized document like before. Also, make sure your color mode is set to CMYK. No red, green, blue. Everyone okay with that? Okay. Now, as far as the requirements go, you can have any shapes that you want using the shape tool or the pen tool. Anything you like. Make any shape you want. All of them, though, have to be set to multiply for the blending mode. So every shape you create needs to be set to multiply. I will count off a point if a shape is not set to multiply, because otherwise this technique won't work. They all have to be filled with a percentage of a single CMYK primary color. In other words, if you're going to fill it with cyan, it could be anywhere between 1% to 100%. Okay? That's fine. You can do that. What I don't want is a mix of colors together in one shape. For you to create secondary or tertiary colors, I want you to create multiple shapes and overlap them. Okay? That's the whole point of this assignment. And that's stated here. You can create and overlay as many shapes as you want to create the colors that you want. They do not have to line up exactly. In fact, one of the examples in here will show you what that looks like. I want you to have fun, though, and be creative. Okay? I'm not looking for, how well do these colors complement one another? I don't care about that. All right? It could quite literally look like a unicorn barfed all over your page. As long as it was set up correctly, that's all that matters. Are we okay with that? Yeah, I'm not looking for on the color wheel, these colors don't complement one another. I'm not doing that right now. All right, but here's the thing. In order for us to see the color separation, because we're printing this on grayscale, right? If you didn't have the composite to go by, or it was really hard to figure it out, it may be difficult to figure out, well, which printout is black and which printout is magenta, right? So to help aid us in this, you're going to typeset your name not once, but 4 times. Okay? And you're going to typeset it 4 times in the 4 different colors. one at 100% magenta, one at 100% cyan, one at 100% yellow, one at 100% black. Okay? In addition to that, I want you to typeset the color names as well. So I actually want you to type somewhere on the page, cyan, magenta, yellow, black, and then set the colors for each of those types. The cyan needs to be 100% cyan, right? The magenta needs to be 100% magenta. That way, when you print out these color separations, the printout that's magenta will say magenta. The printout that's cyan will say cyan. Does that make sense? Now, if you want, one of the examples has it this way. Your name and then magenta, and the whole thing is magenta. Your name, cyan, and the whole thing is cyan. Does that make sense? You can do it that way if you want. When you are done, I want you to set up the color separations. So you're going to be printing this out twice. The first printout, do the composite, right? The overall design, print it like you normally would. Just make sure in the output settings it's set to composite. Then I want you to print it a second time, except this time in the output mode, change composite to those separations. And that will spit out 4 different sheets. Okay? When you're done, put them all together. I've actually stated how you need to put them together here and submit your work. Okay? So I want the composite first, then cyan, magenta, yellow, and black. So in order of CMYK. All right? Once you have those printed out, I've got stapler up here. You can staple them together. You don't have to write your name on it because your name should already be on it. And then upload your Illustrator file. Now, as far as some examples. So here's some examples in the past that we've used. So notice this is a mix of different shapes. A lot of them done with pin tool, but also a lot of different individual shapes. Notice how the shapes don't exactly always line up. That's fine. Some do, some don't. Notice the pants. Kind of give that really kind of weird looking, everyone ever watch 3D films with the old glasses? Not the black ones, but like the old school ones where you have the, yeah. All right. Here's another one. Okay, that one's a bit more vibrant. So, I want you to have fun with this. Create a robot only out of shapes that you've created using the shape tool or the pin tool. But they have to be filled, not stroked, they have to be filled with one of the primary colors. Okay? Or black. Any percentage of that primary color, but you only get one color per shape. So to create those other colors, overlap them. Now, if you want to start off by revisiting your robot from assignment 2 and tweaking that one and turning that one into colors, that's fine. You can do that. Okay? If you want to create an all new original robot, that's fine too. It's totally up to you on how you want to do this. Questions about this assignment? All right. This one will not be due until the end of class on Monday. All right. I was hoping to get through everybody's woodblock, the names that you guys all submitted, before today's class. Unfortunately, I got caught up in a couple of meetings yesterday and I didn't get a chance to finish it. And instead of giving the ones that I had comments already prepared for, I want to do it all at once. So I didn't want like half the class to have the comments and the other half the class waiting. So I'm going to finish those today and get those to you today. Okay. Now, when I do that, I will send out an announcement in Canvas when those comments go out to let you know, hey, I've sent the comments. Those comments may be like, this is great, you are ready for Monday. Some of the other comments will be, you know what, in order to prepare this for the laser on Monday, here's what you may want to fix, or here's what you may want to tweak. Okay? Get those comments, and over the weekend, make those tweaks. Or tweak them when you get to class on Monday. Okay? For the ones that are ready to go on Monday, we'll start laser cutting. For the other ones that need to tweak, in other words, we can put you a little bit later on in the class. In addition to that, though, Open Lab to finish out the robot. Okay. Now, there's one other video I do want to show you. And there are a couple, actually there are two other videos. So this is, again, the color separation. So check this out. So we have a full color photo. right? Just like the one that I have up here. What's going to happen is that you're going to see these screens are going to be pulled away. Each screen is one of the 4 colors. And as they do, you can see how the colors change. So there's the black, just went away. Then the cyan, now the magenta, and then that's the yellow. Does everybody see how that works? So if you go in reverse, so we add the magenta to the yellow. See how that creates that orange, right? Okay. Then we add the cyan. And that, for the most part, creates a full color photo, right? But notice how, like, the saturation of that color, the color kind of looks a little off, right? Again, then we add the key or the black. And that makes that contrast pop. Everybody see that? Okay. Last one. There's been an error. Yes, thank you very much. I like this one. And hopefully I can play the sound on this. By the way, I will, in fact, I will post these in Canvas on our modules. That way you guys can go back and take a look at these if you want to a little later on. But watch this trick.
I've got 3 flashlights here, a blue one, a green one, and a red one. And as you can see, when their beams all combine, you get white light. And if you...
Okay, so everybody see, you put the piece of paper in front of these 3 beams. They're intersecting with red, green, and blue, right? Visible spectrum. And check this out.
A piece of paper with a slit in it, and you block those beams, you can decompose that white light back into its constituent part.
Okay, so what's happening here is very much like a prism. Okay, what you're seeing is because he's got the lights angled, right? He's got them angled at each other. What you're seeing here is that that red flashlight is on the far right-hand side. So that light is the only light that's getting through the slit that's moving in that direction, bounces and refracts off of that white piece of paper. So you're seeing just that red bar, right? The green light's in the middle. So when it goes through that slit, it's subtracting the red and the blue light, so you're only seeing that red slit. Does everybody see that? So that's what's happening here. Now check this out.
Red, green, and blue. Now this is something really cool. If you take something that casts a shadow, it's actually going to cast 3.
What color is it casting? Yeah, cyan, magenta, and yellow. Does everybody see that? It's like, wait a minute, why is it doing that? Well, remember, cyan, magenta, and yellow absorb, right, certain colors, right? So what's happening, what you're seeing here, is that each of those shadows is a combination of 2 of the lights. The shadow, what is being cast as a shadow, it's blocking one of the 3 lights. So in the case of the cyan and the magenta and the yellow lines, each of those lines is a combination of 2 of those 3 wavelengths. So what's happening is 2 of those 3 wavelengths is bouncing off of that white card and combining to create yellow, magenta, or blue in your eye. The third one is blocked by the pencil, right? That wavelength is not getting to the back card. Therefore, it can't reflect and mix with the other 2 lights to create red, green, and blue. Okay? Or white light in this case. Any questions about that? Yeah? And you can see how these colors, these 3, cyan, magenta, and yellows, block wavelengths by this next step. Watch this.
A cyan, a magenta, and a yellow shadow. And if I allow each of those shadows to pass over the slit, you're going to see that they block out only their complementary color.
You see how that works? Subtractive color mode. All based around visible light spectrum. Isn't that neat? So there you go. Now, this is the basics of color. Color theory in and of itself could be an entire semester class. Really it could, okay? But I want you guys to kind of start to get familiar with how these colors mix to create the visible spectrum that we see when we are dealing with mediums that have to deal with reflected light. Okay? Not something that produces light like a monitor. Questions? No? All right, so what will happen next week is we're going to dive into this a little bit further, and we're actually going to talk about the process of printing. So in other words, how in the world we have these 4 color separations, but like in this plate right here, there's areas of the magenta that's fairly light, that's a smaller percentage, and one that's fairly dark. Okay, well, how do they do that? Like, how do they only put so much percentage of ink here versus so much percentage of ink there? And when they're all mixed together, I mean, these inks look pretty solid. How does it work to the point where they all kind of overlay to create something that isn't just a giant blob, right? How do we actually see all of the definition within the print? So we'll talk about that next week as we start to learn about the concept of lithography or lithography offset printing. And more to the point, we'll also talk about halftones. So we'll talk about how these things are actually created. And I'm going to use the dot cam, and we're going to zoom in on this, and you'll actually see how this is constructed, how this is actually made. Sound good? All right, so that's what we're going to be doing next week. Any questions? All right, last part of the class is up to you. You can go ahead and wrap up what you need to wrap up, or you can go ahead and jump and get started on your robot. I will post, I did do a screencast of this. I'll post that a little bit later on to Canvas, and I will post these videos up as well. I'll create a page on Canvas, and I'll post that to the module. I will let you know that in the announcement, as well as when I get your comments back for your block print. All right? All right. Thank you all very much.